So students, we have already completed 2 chapters of Science and Technology NCERT course. And here we are moving towards the 3rd chapter. The name of the chapter is Atoms and Molecules. Now if you remember, we were talking about matter. And we said that matter is made up of atoms, molecules and ions. When we said that the components include atoms, molecules and ions, we just discussed them in brief. Now in this chapter, we are going into the details related to the same. So what is atom? What is it made up of? What are its components? Similarly for molecules and ions. This part we'll discuss in this particular chapter. And then we'll also go into the depths of nuclear technology, radiation, radioactivity, radioactive decay, etc. etc. For now, to understand the importance of this particular chapter, look at the previous year question asked in the year 2001. Now this question says, in a nuclear reactor, self-sustained chain reaction is possible because, and they have given 4 statements. Now in each of the statement, they are talking about neutrons. But unless you know what is a neutron, how can you answer this question? So when you study what is atom and what are the components of atom, you'll find out that there are some subatomic particles which includes protons as well as neutrons as well as electrons. And when you study this basic concept of neutron, after that you have to study the advanced concept related to the nuclear technology. What is a nuclear reactor? How the process goes on in a nuclear reactor, etc. After that, you will be in a position to answer such a question. Okay. Then I'll show you the second question from the same year 2001. A radioactive substance has a half-life of 4 months. 3/4 of the substance would decay in how many months? Now this is a very easy question, but for that, to answer this particular question, you need to know what do we mean by radioactive decay. Okay, so this also we will study in this chapter. Then we have third question. Now this particular question is from the current affairs part, but the topic related to this particular question, or rather if we have to say the core theme behind this particular question, is the same chapter, atoms and molecules. That's why I have mentioned this question over here. So the question is, in which one of the following areas did Indira Gandhi Center for Atomic Research make significant progress in the year 2005? Okay, so I hope you understand that this topic, this particular chapter is highly important for the examination. Now, first of all, we'll deal with the basic part. We started with matter. Okay, so the first chapter we started discussing that everything around us that we are observing, most of that thing is made up of matter. Even if you are looking at this pen, this is also made up of matter. And how did we define matter? We said anything that has some mass and that occupies some space, it is matter. So if this pen has some mass and if it is occupying some space, it is made up of matter. And now here we said that this matter is composed of, or if we have to talk about the components of matter, this included atoms, molecules and ions, right? Now in this chapter we will discuss about them in detail. But before getting into these parts, let's understand this basic part. Now I know you understand what do I mean by space. This pen is taking some space, so you understand what is space. But when it comes to mass, in the first lecture I said you can consider it as weight. Although for your early understanding I said that. In reality, mass and weight, these two are very different things. So let's say, for example, you look at this person who is there on Earth. The person is standing on planet Earth. Here, if you are checking the mass of this person, it will be exactly same even if this person goes to moon and checks his mass. Mass will remain same whether you are on Earth or moon or any other planet in the entire universe. But if you check the weight, the answer will be different. The weight of this person on Earth will be different and weight on moon will be different. Weight on any other planet will be different. So what is mass and what is weight? Well, when we say mass, we're talking about the amount of matter that exists in something. So just for the sake of example, let's say you're talking about me and you want to check the amount of fat that is there in me. What will you do? You will check how much fat content is there in my body. So you'll check my cheeks, how much fat is over here. Then you will check my stomach, how much fat is here. This is how you're going to check it. Eventually, you will conclude that this much fat is there in your particular body, right? Now, similarly, I'm saying that if you're looking at something and if you're talking about the mass of that particular object or anything, then that mass is nothing but amount of matter that exists in it. The real matter, the real content of matter that is there in that particular thing or particular body. Okay. So, if there is this much matter in my body or there is some matter in this particular pen, now you put this pen on earth or moon or anywhere, the amount of matter is not going to change. It will remain as it is. That's why I'm saying mass is something that is not going to change. It is going to remain completely constant. You go anywhere, the mass will remain same because it is the amount of matter that is there in it. Okay. Whereas if you're checking the weight of something, now when we say weight, someone may say, sir, my weight is 40 kg, 50 kg, 60 kg. But here, this weight, the concept of weight, when we are looking at it, it depends on the gravity wherever we are located. So in reality, what is weight? Weight is the force that is exerted on a particular object because of the gravity. So if you're standing on earth, if you're here on the earth, your weight will be different. It depends on the gravity of earth. You go to moon, the gravity is very less as compared to earth. There will be gravity, but it will be relatively less. On earth, it is more. So if you check the weight on earth, it will be way more than your weight on the moon. Getting the point? So weight is the force exerted on an object or anyone, on this human being also. And here the role of gravity is there. So I can simply say, if I check the weight of a person or anything, then it can be different at different locations, at different places, or at different planets. So it is not same every time. It depends on gravity because gravity is different everywhere. So weight will be different everywhere. Okay. Now this is the basic difference. I want you to understand this mass part. Now to calculate how much mass is present in something, the unit that we use is kilograms. Whereas if you're checking the weight, the unit that we use is Newton. Okay. Now, please remember mass because I want you to understand what is matter and the content of matter that is present in you is called mass. And this is going to be very important for us in the next slides or next lectures too. Now, as far as mass is concerned, okay, you're taking mass of anything. Okay, let's say I as an object, I have some mass in me. There is this pen, there is some mass in this. So if you look at anything, any compound, any element, any atom, we are looking at mass. Okay, the matter content. Now in the last lecture, I discussed one thing. I called, there is something called law of conservation of mass. We said that mass or matter cannot be created and cannot be destroyed. So if there is a chemical reaction that is going on, let's say I have taken some wood and I have started burning it. We said burning is a chemical reaction. But before burning, whatever matter was present over here, the same amount of matter will be there even after chemical reaction. And we are saying whatever amount of matter is there in you or any particular object, that is called mass. So that means mass remains same even after chemical reaction. So we called this thing as the law of conservation of mass. I had proved that using a chemical reaction also. I said that there are some reactants on this side. After the reaction, whatever product is there, the mass remains the same. Okay, so this is one property or one law through which any mass in the world is governed. Okay, you do chemical reactions, mass will remain as it is. So that means in the entire world, you cannot create any new mass, you cannot destroy any mass that is existing. It will be remain, it will remain as it is. Now there is second law which we call as law of constant proportion. Now what do I mean by law of constant proportion? So if you look at any chemical compound, let's say you're looking at CO2 or let's say you're looking at H2O over here. This is a compound. Now, in a chemical compound, the ratio of masses of the elements are always constant. This is the law. So, if you're looking at, let's say, H2O, okay, just one second. So, if you're looking at H2O, H2O is a compound. Now, in this compound, what you're observing is there are total 4 hydrogen atoms and there is there are 2 oxygen atoms. So, 2 is applicable to this and 2 is applicable over here also. You will see that if you look at the proportion of hydrogen and oxygen in the H2O, if you check the mass, if you check the content of matter that is there, so there is a proportion. That proportion is 1:8. How the 1:8 is coming into picture? See, you have taken hydrogen atom. If you check the mass in it, we calculate it in grams and kilograms. The mass is 4 grams. The mass is 4 grams. Whereas if you check the oxygen, O2, its mass is somewhere around 32 gram. Obviously, we can say the matter content in oxygen is more than hydrogen. Okay. So if you see when you are taking H2O, if you are taking two different elements and if you are making H2O, you will see the same combination. So 1:8, 4:32 is 1:8. This ratio will continue. This ratio will remain the same. So this, in simple terms, we can say that in any chemical compound, ratio of masses of elements are always constant. So if you have water, whether you convert water into ice or water vapor or anything, it is going to remain the same when it comes to amount of mass. We are discussing mass already. We said in a chemical reaction, neither mass will be created nor it will be destroyed. But now if we are not going for any chemical reaction, we've just taken any compound, we have kept it as it is, we are saying the mass of elements that are present in it. Now if you have not understood H2O, you can look at CO2. Whatever is the mass of carbon, whatever is the mass of oxygen, and whatever is their ratio, this will always remain constant. That combination will not change. Whether you have this much amount of carbon dioxide or this much amount of carbon dioxide, whether you change its state from gas to liquid, liquid to solid, whatever you do, the amount of mass with respect to each element is going to remain constant. Means the ratio will remain constant. The same ratio will be there. Clear? So this is just a basic principle through which mass is governed. Okay. Now the main part of discussion for today is atom. We said matter is made up of, or we find the matter in the form of atom, molecules and ions. So the first question that comes up in our mind is, what do we mean by atom? So let's say we look at anything. I'm looking at this pen. I'm saying the pen is made up of matter. Now when I look at that matter, if I zoom it, if I try to check the smallest unit of it, smallest particle of it. If I start dividing it, for example, let's say I have this pen and I have divided it into two parts. I have broken it. Now it is in two parts, two different pens. I take one piece of it and then I break it also. Then I break that smaller part into way smaller parts. I go on dividing. So there will come a stage wherein I'll get the smallest particle or the smallest unit of the same matter. Smallest, which cannot be divided further. We can normally say it's an indivisible unit of matter. That smallest part of matter is called as atom. And we say that whatever is the property of a particular element that will be present in the atom. For example, I have taken oxygen. Okay, oxygen. I have taken oxygen, or let's say I have taken carbon, or I have taken nitrogen, whatever. These are elements. So I have something which is made up of oxygen or carbon or nitrogen or something. I am dividing it to see its smallest part or smallest unit. So whatever I get at the end is the atom of carbon or atom of oxygen or atom of nitrogen. That is the smallest unit which cannot be divided further. Now this was assumed that it cannot be divided further, but we have some other studies which claim that we can even divide it and come to know about the subatomic particles. But for now, just look at atom. Okay. Now whatever is the property of oxygen, you will find the same property in the atom of oxygen. It's the smallest part of oxygen that has the same property which oxygen has. For example, which property? Well, if you bring oxygen closer to a fire, the oxygen will burn, right? So the same property will be there with this smallest unit. Okay. Now, structure of atom. How does atom look? So we have an image. Atom looks somewhat like this. Although you can't see it with your naked eyes because it is very small. We count it in nanometers. Usually for normal calculations, we use the unit of meter, centimeter, etc. But if you are looking at the radius of an atom, we go for nanometer scale, which is very small. You can't see it with your naked eyes. Okay. So this is the structure, or this is how an atom looks. In this atom, you will find some interesting thing. That this atom looks it in such a way that here at the center, there is a nucleus. There is a nucleus. And this nucleus is very dense. Whatever is the mass of this entire atom, most of it is there in this nucleus only. It is very dense over here. And around this particular nucleus, we see some smaller particles, or what we call as electron, which are orbiting. So here we have a nucleus, and around this nucleus, some electrons are just moving. Some electrons are moving like this, some are moving like this, some are moving like this. Okay. So there is a dense, very dense nucleus. If you are calculating the mass of an atom, you will look at this region. You will not look at these electrons, because electrons are having very negligible mass. You don't even need to consider it. Now, if I specifically talk about this nucleus part, we earlier said that atom is the undivisible part, or when you have divided matter into smaller part, the smallest unit which you have got is atom. So earlier scientists thought that we can't go beyond atom. We cannot see what is atom made up of. But later on, studies have claimed that even atom can be divided, and there what you will find is a subatomic particle. Now, which are these subatomic particles? Well, proton, neutron and electron. These are subatomic particles. Now see, I said electron is orbiting over here around this nucleus. But if you look at this nucleus, what is there in the nucleus? So in this nucleus, there are two different subatomic particles. One is called as proton, another one is called as neutron. I hope at least this basic part is clear. Okay, so any matter, if you zoom, if you take the smallest part of it or smallest unit of it, it is atom. Now if you look at the atom, it looks somewhat like this. It has a dense nucleus which has protons as well as neutrons, and around this you will see some electrons moving or orbiting it. Clear? Now when I look at this proton, when I look at this electrons, when I look at this neutrons, I see some interesting thing, and I call that interesting thing as charge. We say that proton that we see in the nucleus of an atom, it is a positively charged subatomic particle, whereas the electron which is moving around, which is orbiting, we say it is a negatively charged subatomic particle. But you may say, sir, what do we exactly mean by charge? So I can say charge is a kind of force that is there. Now this force will let you either attract or repel each other. For example, if something has positive charge, some other thing has a negative charge. Now what will happen? Both of these things are going to attract each other. They are going to attract each other and they will come closer. So the force that is there inside each of these, that we are calling as charge. Whereas if there is, let's say, something with positive charge, some other thing with positive charge, now what will happen? They'll not attract. They're having same charge, they'll not attract, they will repel each other, they'll push away each other. Okay, so we can say simply charge is a property of matter wherein the particles inside that particular matter will either attract or repel each other. That is called as charge. Now this charge could be either positive charge or negative charge. Okay, and interestingly, when we look at these protons, so the blue color over here, it is proton. So the protons in any atom are positively charged subatomic particles. Protons, if you look at the atom of any particular element, if you go for any atom, in that atom there will be some protons, there will be some neutrons, there will be some electrons. If I look at protons, they are always positively charged. They are positively charged, that's why we have given them the name proton. Whereas in reverse, we have some electrons, and these electrons are negatively charged. Okay, these are negatively charged. So to briefly say what is the structure of atom. So we have a nucleus, very dense, and at the central part of that atom, which includes protons, which are positively charged particles, and we represent them with P plus. Okay, then we have neutrons, and these neutrons are not having any charge. See, we said either you will be positively charged or negatively charged, but third stage is you are not having any charge. You are having no charge as such. Such particle will be neutron. So we represent it with N0. Okay, and around this there is a cloud of electrons, and these electrons are negatively charged particles who are orbiting the entire proton and neutron structure or nucleus, and we represent them with E minus. Clear? These three things: proton, neutron and electron. Positively charged, negatively charged, neutron will be neutral. They won't be having any charge as such. Clear? So this is the structure of atom. This is how an atom will look. Now see, if you look at any atom, basically in a normal situation, or when we are looking at an atom and we are saying this atom is neutral, that means we can see there is an atom which is very stable, which is present over here. we will see that the number of protons and number of electrons in that atom will be same. So let's go back to this slide. I am saying the proton, this blue color part, the number of proton, let's say number of proton in this particular atom is 6, and all this 6 is a positively charged particle, right? Proton, I am saying number of proton in this atom are 6, and all these are positively charged. Proton is a positively charged particle. In this atom we will also find total number of electrons also 6, and electrons are negatively charged particles. So interestingly, we have exactly equal number of protons as well as equal number of electrons. One is positive, one is negative. And because the positively charged particles and negatively charged subatomic particles are same, that's the reason this atom is in a neutral form. There is no attraction, there is no repulsion, nothing is taking place, and this atom is very, very stable. Okay, this atom is very, very stable. And that's the reason it is existing in a normal form. So I'm saying, if you're looking at this pen, this is made up of matter. If you go and check the atom that is there inside this, then in this atom, whatever number of proton and electron are there, they are equal, and there is no charge over here. That's why this atom is not having any charge. It is very, very stable. Okay. Now what happens if the number of protons are not equal to electrons? So let's say there's an atom in which there are 6 protons, P plus, and only 5 electrons. Now this is not stable. Certainly this atom will not be a stable atom. Or exactly reverse situation can also be there. So let's say there are 5, or let's say there are 5 protons and let's say 10 electrons, just for the sake of example and see. So it could be a situation wherein protons are more or electrons are more, anything. But my point is, if there is such a situation wherein protons and electrons are not in same numbers, that means either your atom will have extra positive charge or negative charge. Simply, when we said we have 6 protons and 4 electrons, so plus charge is 6, minus charge is 4. So protons are more. So when protons are more, that means positive charge will be more. So this is going to be a situation wherein this atom will now be called an ion, because there is a charge. When you add a charge to any atom, then it will be called an ion. And here, because it has positive charge, we have given the name cation. Positive ion is also called as cation. Let's say if there is a reverse case, wherein protons are less than electron. That means negative charge is more, there is less positive charge. So it's a negatively charged ion, and this will be called as anion. So these terminologies you should know, that if protons are more than electrons, this atom will get a positive charge, and that's why we will call it as a positive ion or cation. In case protons are less, electrons are more, then this atom will have a negative charge. It will be called a negative ion or anion. Clear? This much clear? Now see. Earlier we said when protons and electrons are equal. If we go back to this image, here we are saying if, let's say, number of proton or positively charged particles are 6, and those who are orbiting these negatively charged subatomic particles, they are also 6. In that case, this atom will be stable. But out of these 6 electrons which were moving, we have taken 1 electron. Let's say this atom has given away 1 electron. So now it has only 5 electrons left. Now, do you see the stability? No, it will not be stable. Now this atom will become unstable. It will not be neutral. It will become unstable. Now here, because it has given it, so positive charge is more, so it will be cation. In case it would have taken extra electron from someone else, some other atom, then it would have become 7. So 7 electrons and only 6 protons. That means negative charge would have been more. So we would have called it anion. And in both these stages, we are saying the atom is highly unstable. And whenever any atom is unstable, it will not remain neutral. It will try to combine with some other atom. So here it will try to react with other atoms or other ions, and they will form some kind of bond. Let's say we have sodium represented by Na, but it has a positive charge over here. That means it has lost some electrons. It has more protons and less electrons. That's why it has positive charge. And we have another one, that is chlorine. But what kind of chlorine? Wherein there is an additional charge, that is a negative charge over here. So in this case, both of them are unstable. If you have kept them together, they will try to come closer to each other and make a bond. So Na and Cl will make a bond, and we will see NaCl, that is our common salt that will be formed over here. Now they will be stable. Now they will be stable. So to simply put, in an atom, there are some protons, there are some neutrons, there are some electrons. Usually you will observe protons equal to electrons, and this thing will make this atom neutral. But if it is not the same, then this atom will be unstable. It will get converted into ion. There will be a charge on it. So it could be positive, cation, or negative, that is anion. And it will react with some other atoms or ions and try to become stable. This is the story of atom. Clear? This is the entire story of any atom. Okay. Now, further we are moving towards the periodic table. And there is one concept called the concept of atomic number, and another one is mass number. You should know what is atomic number and what is mass number. First of all, when you are looking at any atom, let's say I have taken carbon. Okay. So carbon is an element. Okay, carbon is an element. I have taken one particular atom of carbon. In total, carbon has 6 atoms. If you take carbon, you will find there will be total 6 atoms in a carbon. Okay. Out of those 6, I have taken just one atom. Okay. And in this, if I look at the number of protons that are there, what will you see? How many total number of protons that are present in the nucleus of one atom of carbon? That number of proton will be called as the atomic number of carbon. So whether you take carbon, oxygen, nitrogen, whatever, if you take their one atom, if you zoom and if you see how many protons are present in that atom, that number of proton will be the atomic number of that particular element. And why are we so much serious about the number of protons? Because protons is the real identity of any particular atom. So if you're looking at hydrogen, if you're looking at carbon, if you're looking at oxygen, you're saying all these three are different. Hydrogen is a gas, carbon is a gas, oxygen is a gas. But how are they different? They are different because in each of the atom of these elements, the number of protons are different. In hydrogen, you will just find there is one proton. Okay, in hydrogen I am saying number of proton is just one. In carbon you will find it 6. In oxygen you will find number as 8. And this is how we are saying that how many number of protons are present. This differentiates one element from the other. This differentiates one atom from the other atom. Otherwise, if number of protons were same in every atom, then everything would have been same. Everything is different because number of proton present are different. So in oxygen, there are 8 protons. In hydrogen atom, there is only 1 proton. Okay? So this is how we are saying the identity of any particular element will be based on number of protons present in it. Now, you may say, sir, because we have oxygen and this oxygen has total 8 protons present in it. What if I remove some protons? What if I make it 6 protons, or let's say I make it 10 protons? Will it remain oxygen? The answer is no. As soon as you change number of protons in any atom, any element, that element will not remain the same. It will become a different element altogether. Its chemical properties will be completely different. That means whatever is the number of proton, that is the real identity of any element. Clear? So because we know that this number of proton matters, so we gave this name called atomic number to number of protons of any element. So now we identify any element by the atomic number of it. And what is atomic number? Number of protons present in the atom of that element. Now, whatever elements we know or the scientists know, they have put it on a scale of table or on a particular table. So here you see, there is hydrogen over here. Hydrogen has only 1 proton present in it. So its atomic number will be 1. So here at number 1 you have hydrogen. Then you have helium over here. Its atomic number is 2. It has only 2 protons, and that's why its atomic number is 2. Here you have lithium. In lithium you have total 3 protons. That's why we have put it over here. Its atomic number is 3. Similarly, if you look at carbon, I said it has 6 as atomic number. It has 6 protons. In oxygen, total 8 protons. And this is how entire periodic table is made. So whatever elements scientists know till now, those are added in the periodic table. In case there comes a new study or any new discovery wherein we find out some more elements, then those will also be added in this periodic table. Clear? Now, one thing is clear, even this entire periodic table is made up considering the atomic number of each element, and this atomic number is number of protons. We represent atomic number with the letter Z. With the letter Z. Okay, just for the sake of representation, we use Z. Now, this is atomic number. There is another concept called as mass number. Atomic number is different, mass number is different. When we are saying mass number, we are talking about the mass, the matter content that is there in anything. That is the mass number. So if I have to take carbon or nitrogen or anything, I know the atomic number. I know the atomic number of carbon, that it is 6. There are only 6 protons present in carbon. But I want to know how much mass is there in carbon. If I take any atom of carbon, how much mass is there? Or what we call it as, what is the mass number of carbon? So if you have to calculate the mass in a atom, what do? If we go back, you see this was the atom. I said that there is nucleus which is highly dense. So if we have to calculate mass, we have to just look at nucleus. We don't need to consider the electrons moving around because its mass is negligible. You don't even need to consider it. The real mass is there only in this nucleus. And in the nucleus, proton as well as neutron, both these things are present. So if I have to calculate the mass number of this atom, I have to take proton as well as neutron. So to simply say, mass number is the sum of protons and neutrons of any particular element or any particular atom. Okay, so let's say I have oxygen atom. In the oxygen atom, I find there are total 8 protons present, and also there are 8 neutrons present. Sorry, neutron will have 0 charge, and also 8 electron present. Okay, now if I ask you what is the atomic number of oxygen, atomic number I said, so what do we say? The number of protons that are present, that shows the atomic number. So number of protons are 8, so 8 will be the atomic number. But if I have to calculate the mass in oxygen atom, so the mass number will be represented by the entire nucleus, which includes protons as well as neutrons. So 8 protons, 8 neutrons. Will not consider electron at all because the weight of mass of electron is negligible. So 8 plus 8, 16. So the mass number of oxygen is 60. For every element, this atomic number and this mass number is going to be different. We represented atomic number using the letter Z or Z. We represent this mass number using the symbol A. So we take any particular element. Let's say we have taken carbon, or let's say we have taken oxygen, anything. Here you will mention its mass number, and here you will mention its atomic number. This is how we represent it simply. So if I have to take the case of oxygen, so I'll write O, then atomic number, that is Z. I'll write atomic number 8 over here, and mass number A. So here I'll write 60. This is how I represent oxygen. Its atomic number is this, its mass number is this. And now I hope you understand the difference between atomic number and mass number. Clear? Now, further we'll study the remaining part. Just remember this image. Just remember that there is a nucleus, there are protons, there are neutrons, and there are some electrons. And the core weight or core mass remains in this nucleus. Okay? Thank you.